Hello, I'm Peter Diadamo,
And Tara Nyack.
and we are working together to prepare this short video to show you some of the interface associated with the uBiome module in Opus23 and a quick tour of some of the basic apps that are provided in the program. Utopia basically is a free add-on module that allows you to look at microbiome raw data as supplied by the uBiome service. So in order for this module to be useful, you have to basically have the client go to uBiome and get a submission kit very similar to 23andMe. It comes in the mail. They provide a fecal sample, and away it goes. And a couple of weeks later, they get notified by email that their data is ready, and essentially they get to the uBiome website and sign in with the information. Now, typically, most patients that I know are not very data savvy, and so typically they send us the login and we go ahead and download the raw data. I don't know if you do that with 23andMe in your practice, but some patients are basically pretty good. They send you the zip file for 23andMe. Other patients just say, listen, go get it. I don't know how to do it. But so basically, assuming that either A, they sent you the data, or B, they've given you the login, in this case, you would simply go to the back end of the uBiome, what they call the Explorer, and click under Samples. And, after you sign away your life, there are samples here. In this case, there's two samples. You would click on Explore Sample, if whatever one you want to download, and then you go to where it says Advanced here and Downloads. Okay, so basically it's you have to select what particular uBiome sample you are interested in downloading, and of course the thing with uBiome, which makes it quite different than 23andMe, is 23andMe, unless you basically get another release or something, you download the file once. With uBiome, you can have obviously multiple tests done over intervals, and the Utopia module allows you to actually download multiple uBiome files. So you will go to Downloads, and this is where you want to basically be quite certain. You want to download the taxonomy data. So in other words, you're going to download taxonomy, and you're going to download the taxonomy in what's called the JSON format. JSON is just a particular type of file. For instance, you have text files, zip files, doc files. Well, this is just a particular data way of organizing things. You click on the JSON file, and it gets a little tricky here, but once you master it, it's not too bad. Essentially, unlike 23andMe, where they get very nice about the whole thing and you download the zip file onto your hard drive, the people at uBiome simply just send it out to the screen. Okay, so now basically you have to go into your browser and basically save as. Okay, so where you go in the browser, if you're in Chrome or whatever, you go up to File, Save As, and then you can give it the initials of your patient, or you can give it your dog's name or whatever, and .json, J-S-O-N. Save that to your hard drive, and basically you're ready to go. So the procedure is a little wonky in the sense that they just don't make it particularly easy to download a file. It goes to the screen, and then you have to save as. But once you master that, and like anything else, you do it once or twice, and it's pretty straightforward.
And you have to make sure that when you save it, that you save it as a page source, not as a web source. There's a little option at the bottom, so if you don't flip that over, then it won't save.
Right, because what happens is if you save it as HTML, it's going to embed HTML characters in the file, and it's going to be rejected by Opus23 Utopia because it can't parse it. So normally, if you wanted to basically save it, make sure that you're saving it as a
page source,
or most of the time, listen, the end result is that you can figure it out for your browser. Most of the time, typically, the default situation works for most people. I know it does for me. Other people have said no, that they had to adjust that setting. There's all sorts of issues here with regard to this, and if you're a user of Utopia in Opus23, then really your best bet is to be part of the Facebook group on Datapunk, and if you're having any additional issues, we can make sure that we solve them right there. But basically, like I said before, 9 times out of 10, the default condition on the browser is such that all you need to do at this point is go save as, and away you go. And at this point, it says save as JSON, so we're going to not do that because I already have a JSON file that I loaded onto the hard drive to spare me this additional download. So what we've done is we've gone to eubiomes. We've logged in either with the patient ID or the patient's given us the JSON file. We've got it on a hard drive. One way or the other, you got the JSON file on your hard drive. Unlike 23andMe, which is a huge file, something like by the time you unpack a zip file in a 23andMe zip file, it comes out to be between 10 and 15 megabytes. Zip file is 5 megabytes. The JSON file for eubiome is maybe 60 kilobytes, so it's a much smaller file, much faster upload and everything like that. So now basically let's go back to Opus here. So now we have our client. We already have Utopia data on this client, by the way. So we're going to add it. We're going to add some more. So go to File Function, Upload Utopia data. And you don't have to, it already knows because I've already loaded my client, Leolangio Mysterioso, so we know that the file is going to be linked to him. And click on Choose File. And we go to Desktop and have the JSON, and then we upload the file, and miraculous things happen. And what happens now is Utopia is really trying to make sure that the file is a parsable JSON file, and turns out that it was. So everybody's happy. So click here to list Utopia files. At this point, we have 3 eubiome data sets on Angelo here. So let's go ahead and load the most recent one. You work as in Utopia, it's different because once you load a client in regular Opus, you've only got that 123andMe file. Here you have to tell it which particular report you want to work with. So they're always organized in descending order, so the latest one's always at the bottom. Load this report. And here we are. We're at the eubiome Utopia interface. And you'll notice here now that the environment has changed. We have an orange bar that is identifying that you're in the Utopia program versus the blue bar, which tells you that you're in the Opus program. This little, let me just reload that. This little menu now shows up. Like Opus, there are a lot of very similar functions. You have a series of apps that are analytics. You have an app that basically does algorithmic analysis based on the outcomes. You have some apps that are basically designed for prescriptive advice. And essentially the apps basically pretty much work the same way. So if you're comfortable with the interface for Opus23, I mean, you're going to be very comfortable with the interface for Utopia. It's largely the same things. I mean, so let's look at really the equivalent in Utopia of the Opus Argonaut app. So, you know, what's the first place most people start in Opus23? Is they fire up Argonaut, they start looking for SNPs and things. Well, that's an app in Utopia called Loam. So if we go to Loam, we can see that Loam looks surprisingly like Argonaut. And the reason being that it has a depiction of all the various taxons that were reported in the eubiome report. And there's a couple of things that you have to understand about bugs, which are different than genes. Genes, you know, you either have a C or a T. I mean, it's a pretty straightforward type of analysis. I mean, you know, so it's kind of much more hard in terms of the conclusions. With microbiome data, it's very difficult because a lot of times people have significant variation in their microbiome that's just part of a normal situation. So in many respects, we're looking at playing numbers here. And of course, anybody who's in, you know, clinical sciences knows that, you know, what's the most normal thing that you use to determine normal? Standard deviation, right? So if we can have a basic fundamental idea of what the average is and what's the typical standard deviation for the appearance of a particular bacterial, and everything in, you know, for instance, I know in Opus 23, everything is an RS number, and in the world of microbiome, everything has a taxon ID. For instance, even human beings have a taxon ID number. So every species, every genus, and it's all organized hierarchically. So for instance, if, again, just looking at if you remember from Argonaut, you can sort typically by any number of the different columns. And I sorted by, in this case, rank, and this hierarchical structure, phylas and orders and families and classes and genera and then species, everything drills down eventually. Now, we have to understand a couple of things about the technology that's used by Ubiome, which is that it's typically able to identify certain species with some reliability, but the idea of being able to have complete reliability at the species level is a little bit beyond the technology. So most of the time we're trying to draw conclusions based on genus or genera. But where we have species data, it'll certainly be shared. So in this case, basically, you're looking at a depiction that is pretty straightforward. We have our bacteria taxons here. We have some little insights as to whether or not these guys are good or bad for you. If you see a little green exclamation point, it means they typically probably do something good. If you see an orange, yellowish exclamation point, it means basically that it is mixed. So for instance, if you hover over it, it will even tell you a little bit about the way that the categories that maybe resulted in this. And then if you see the red exclamation point, it means there's probably something bad. In this case, this one is a dysbiosis pathogen associated.
This is where I tend to first filter by reference.
Sure, you can also, you can certainly do that. And it's also, again, giving you insight as to whether or not these bacteria or these microbiota have been sent on to curation. But we haven't got there yet, so obviously there's not a lot of things curated because we haven't curated anything. Looking at it from that perspective, we can see essentially, okay, here's the fundamentals of the math, right? In this case, the average for Clostridia is 28.6%. This person has 44%, but there's a huge standard deviation. And so the interpretation was that it was within normal limits, although there was a variance that was greater than 30 degrees from normal. So essentially the normal variance here is only going to show you just really whether or not, in all honesty, calling it within normal limits was really honest or not. I mean, if you've got a huge standard deviation, you sort of have to be careful about whether or not you really want to just simply call it normal. So this gives you a little bit of insight into the nature of the standard deviation. And then here's the order of magnitude. And order of magnitude is a power of 10. So for instance, 2 orders of magnitude is 100. And so typically when a person has 2 orders of magnitude, it means that the percentage of microbiota of that particular type is almost 100 times greater than what we would have normally seen in the averages. So in this case, you can see here that it goes to +6 standard deviations. And so typically when you start to see +6 standard deviations, you're really mathematically getting the impression that you're on relatively firm ground, that this is something happening in this client that really isn't really typical. And again, remember the nature of, well, a couple of things you have to understand about microbiome that I learned in working with it and developing the database for it, is that most of the species that are in the conventional commensal microbiome are not the ones I learned about in pathology of microbiology that I learned in med school. Okay, so there's an entire range, perhaps maybe as many as 300 or 400 different species and genera that constitute the so-called microbiome that actually we have sometimes precious little information on. I mean, and hopefully, as things get further along, we'll start to be able to understand that a little bit more. But nonetheless, just like using Opus makes you smarter because of all the information pop-ups, clicking on any particular microorganism in Utopia will make you smarter too. So you click, in this case I clicked on Rosboria, which is a common butyrate-producing bacteria, and you get essentially the description of the importance of the bacteria and then the tags. And Rosboria is associated with being a keystone species. Keystone species is considered a bacteria, microorganism that exerts a critical hub-like effect in terms of the interaction webs. That, for instance, they produce typically a substrate, or they metabolize they metabolize a substrate that typically is relied upon by a subsequent succeeding generation of microbes, that without that conversion, that the process would have been interrupted. So just like a keystone in an arch, a keystone species is critical to, amongst other things, being able to have that second generation of microbes, and that's critical to developing diversity and all other things that are associated with being healthy. And typically, I mean, if you're interested, you can click on these things. So if you wanted to get an idea of the particular species that are listed as keystone species, you can do that. And then that would simply take you to another information screen. So here what we're seeing is that Roseborrea, which is a butyrate producer, first order, at high levels can be sometimes a sign of dysbiosis. That's why it's very hard to say, you know, this would be one that would probably get an orange exclamation point. There are certain species like Roseborrea and Blaudia which you like to see growing in people, but you don't like to see them too high, because in essence, if they get too out of control or too predominant, they actually start squashing the other guys. So you want them, but you want them essentially well behaved. In this case, the client has a positive 1, slightly higher standard deviation. As we go down to the bottom of the information screen, sort of more magic happens. Okay, so remember what I said, everything in the microbial world is hierarchical. So we're getting all the, in this case, since we clicked on a genus, we're getting all the descendants, which are the species. We also get information on interaction webs. So for instance, studies have been able to have been done where you've got linear matrix correlation data, and we understand that there's, for many bacteria taxon, we have inhibition and enhancement data. So for instance, typically Roseborrea tends to enhance the growth of certain species, but the presence of Roseborrea in large amounts actually tends to inhibit these other species. And then of course the inverse is true. There are certain species that basically enhance Roseborrea and other species that inhibit. They're not necessarily the same. So what Roseborrea does is not necessarily the same as what's done to Roseborrea.
This is kind of like your gardening manual. This is where you start when you're looking into affecting somebody's microbiome, you know, without just throwing probiotics down the hatch.
Mm-hmm. Mm-hmm.
And interestingly, you know, in our clinic, since we've started using Utopia, I can't think of one time that we actually had an effect on a patient or tried to have an effect on a patient on a microorganism that I actually knew. All of these are completely new.
Yeah, that's the funny part about the whole thing. And the interesting thing about, you know, and I mean, I'll just take a step back and just once again reintroduce the concept of the fact that, you know, Opus23 and the Utopia module are based upon generative principles in terms of the programming structure, in terms of the data structure. And, you know, typically the first step in any generative type program is you generate a huge amount of data so that you can then subject that data to modeling and simple algorithmic things, heuristics and stuff like that. And, you know, writing Opus23, it was pretty easy to figure out how to get data. You just oftentimes would go particular places and get it. Geneticists are people who often deal with digital data. It seems microbiologists spend an awful lot of time still in books. And so in essence, one of the things we really had to do was to be able to hand develop this database. And then we get down to things like where we talk about the individual metabolomics for that particular species. And you can see here that we've identified for Roseborrea the following substrates and growth factors and metabolic end products. And this is where the magic occurs later on when we do some agent curation. Also, too, an ability to structure a network-like approach to be able to bioengineer relies, the combination of the interaction web data and the metabolome data really are critical to being able to synthesize an approach that's actually rational.
And we should mention that the curation button is there just like in Opus, same way, sending something to the report.
So yeah, basically if you want to, at a certain point now, if you want to have a report that basically features Roseborrea, well, let's see what happens. Let's curate it. Okay, so now Roseborrea is saved to curation, which means that when we go on to generating the client file, that's going to be part of the client report, that's going to be part of the description. So again, here, this is, again, if you're familiar with the Argonaut, you're going to be very familiar with Loam. So then let's go look at Spectrum. Spectrum is more of a community organization with a lot more emphasis on visuals. And the idea being is to try to come up with an idea of what the general community characteristics are. And so we get the very attractive pie chart, which gives you insight at the genus and phyla levels. Everything is clickable. So for instance, if I wanted to learn about Intestinobacter, I can click on that. And then there's a little profiler at the bottom here that gives you, by categorical approach, how many species qualify as keystones, how many species have been identified as known pathogens, how many are part of the oral microbiome, how many are capable of secreting histamine, and so on and so forth. So pretty straightforward.
This is more powerful than we give it credit to, though, because this profiler sort of gives you this broad spectrum picture, and you can really quickly look and figure out, especially the butyrate producers.
Sure. And you can click again if you want to know the inside story. You click, and it tells you the ones that are in the client sample, and it tells you the ones that are not in the client sample.
Yeah, this is a good starting point if you don't know where you're going.
Yeah. So as far as that goes, I think the benefit of Spectrum is that it allows you to sort of get a thumbnail sketch. It's kind of almost the equivalent of the Strobe app, I think, a little bit in Utopia. The Pansofia app basically gives you the opportunity of being able to sort of look at sequential data, and what we're going to do here is, let's say we wanted to look at levels of allostepes, and let's say we wanted to add
Oh, I love Pansofia because this is where you can visualize and show your patient a visualization of how your interventions changed their picture.
Yeah, we can choose bacteria that we want to display, and what happens is it depicts the two intervals. So in this case, we have two tests here, on 421 and on 915. So in this case, the allostepes dropped from 7.7% to 2.6%. Then you'll see two little dots here. This dot is giving you the percentage of change. And this is a kind of an interesting chart because it's a multi-axis chart, so you have two different y-axes. So this axis is depicting this. So this was a lot of change. It has a negative 66% change. To give you a grounding in what the average is, we produced this little orange dot. Okay? So in this case, this person had an allostepes that was above average, and then on the subsequent visits it went down to below average. Now, we can also go back to the situation here, and let's say you don't want to tick particular bacteria, but you're interested in maybe looking at dysbiosis associated. So with clicking on here, we'll simply just give you all the bacteria associated with dysbiosis. And sometimes the numbers can be a little small to try to get hold of, and so if you click hold, it'll zoom in that area for you. And then if you hit this button, it goes back to normal.
And you can curate this, which is great.
And this actually is available to be sent to the client report as well.
And this is what we've been doing. We've been using the printable version to sit down with patients and show them where we've made change.
And actually now it's embedded in the report as well. So what Pansofia really gives you is the ability, again, to go back to the main screen, the ability to have a chart composed of the particular species you're interested in, or to just go by the particular category that you're interested in. You're looking at butyrate producers or core microbiota or probiotics. That'll pre-shrink the choices for you. And like Tara said, I mean, this can be curated and sent on to the curation program as well. That generates the report. So here we have done the analytics section. We looked at Loam, which is fundamentally like Argonaut. We've looked at Spectrum, which is kind of a community, more of a global-based way of looking at things, and we looked at Pansofia, which is more of a sequential analysis tool. We go to algorithms, and if you've used the Lumen app, this is going to look very familiar, but basically Advice is the app that runs the algorithms in Utopia. So in here we can see that there is a positive algorithm which shows a dysbiosis typical of autism. The description here typically is very similar to the algorithm descriptions in Lumen, except here we're actually giving the particular bacteria that were involved in making the algorithm true or false. And because of the algorithm's true nature, we can then, if we've identified problems with particular elements of the algorithm that are either too high or too low, the Utopia will actually embed the certain suggestions into this process here. So for instance, not only is the algorithm basically giving you insight, but it's actually making suggestions with regard to agents. But even more interesting as well, and this is a little bit different than Opus 23, is that once you run the algorithm the algorithm app in Utopia, Advice, once you've run it once, Advice actually saves these agents and adds them to its calculations when it actually produces an agent curator for you, which is something like very similar to what you would do in Opus. In other words, what are the kind of things you're going to want to suggest that the patient take. So one of the unique things about Utopia is that Utopia actually factors in the outcome of the algorithms in addition to the overall analysis of the microbiome in determining a certain value for whether or not certain agents are better indicated than others, and which would be the highest indicated ones or the ones that would be most likely to want to be encouraged or discouraged. So we got another here algorithm for an autism dysbiosis, and we have here a dysbiosis associated with FUT secretor associated status. And then here's the power of being able to weave Utopia into Opus 23. Not only is Utopia running on microbiome data, but remember, at any given moment, it can ping Opus for the genetic data on the person. And so we can use actual insights into the person's 23andMe data to calculate their secretor status, in this case, in this algorithm, and actually wind up being able to draw conclusions about whether or not the particular genuses that are in question are sufficient for a person who has that particular genetic makeup. So in this case, for instance, we have bacteria that are associated with FUT2 secretor status that are missing in this person. And that's a conclusion that can have only been drawn, obviously, if the program knew the secretor status, which is obviously the power of where we go. The initial stages of Utopia really are basically very simple, but as we go forward into the future, I think the bigger area that's going to have the potential is going to be just constantly keep weaving genetic and microbiome data and synthesizing it and mashing it up.
And it does it for you. It automatically pulls the data from Opus. You don't have to flip back and forth between the programs.
Right. It's all in there all at the same time. Here's another algorithm that shows the person has a potential for high oxalates based upon the lack of 2 oxalic acid metabolizing bacteria. Here's the association for methanogenic phenotype with SIBO. I mean, I think one of the things about this is you can see that there's a huge, I can go on and on about this. Some of these algorithms are just awesome. This is an analysis of deconjugation activity by virtue of the microbiome. Here's an algorithm that shows that there's a dysbiosis associated with increased intestinal permeability that probably has to do with bacteria that are interacting with zonulin. We have bacteria issues that are related to taxa of general dysbiotic status. Reasonable diversity, presence of certain TMAO producing strains, sensitivity to gluten-induced immunopathology. And again, like I said before, one of the great things about the Advice app is that it actually generates, because it generates agent data, this can be woven into the agent calculations, but also at the bottom of the algorithm page, you get the actual cumulative aggregate count of things that show up as being particularly useful for the client based upon these algorithms that are true. Again, the goal of this small video is not to explain every single nuance and every single line, but to get you familiar and to make you comfortable with the idea that basically the interface that you've probably become comfortable with Opus 23 just continues on with the Utopia. Prescriptives, this is where you sort of get into the erector set thing. Radiance is an interesting app. For instance, let's say we want to have, Akkermansia is a real nice bug. It does a lot of cool things, and the client doesn't have any. So we're going to click the little green box. Green box means please find things that are going to make this increase. And we have, let's say, a certain bacteria here like Catabacter or Collinsella. So now that's a bad boy. And this person's got a lot of it. So in this case, we're going to click the red box, which tells the program, go find things that make this guy get smaller. Go find things that interfere with him. And let's block Enterobacter. And let's try to increase ways of finding, let's find something interesting here. Let's think about this. Let's see if we increase intestinal bacteria. Okay, so I've selected a bunch of bacteria. I selected 2 bacteria that I'm interested in increasing and 2 bacteria that I'm interested in decreasing. Then we hit this button and magical things happen. Yay! So what do we wind up with? We wound up with a network associated with the things that are going to basically have an effect on those goals. The big guys, the ones we're interested in, are the big nodes. However, the program actually went into the interaction web, found the species that are either known to inhibit or stimulate, and have given us insight into the things that might be able to be used. For instance, in this case, we're interested in increasing acromantia, right? Well, here are the primary things that might help with acromantia, but it also turns out that acromantia is enhanced by the presence of Ocelospira, so we wound up with some secondary data on that as well. For instance, same thing here. We want to decrease, you'll see here, Collencella is one that we're interested in actually getting rid of, and you'll see here Bifidobacteria inhibits Collencella. So we're looking for things that increase the growth and effectiveness of bifidobacteria. So this is kind of like that old saw that the enemy of my enemy is my friend. In this case too, for instance, in this case, if you wanted to increase Holdermania to have the effect of inhibiting Collencella, you could recommend the person get some chemotherapy, I suppose, but I don't think that's a wise move. So the reality of the whole thing is that here, again, you can curate this, in which case the interaction web would actually be present in the report. But really, this is the bioengineering app in the program. I mean, this is really where you try to figure out not necessarily how to treat the bacteria itself, but to restore a certain effectiveness to the overall interaction web. And this is probably why the fecal transplants work so well, considering that we have no insight as to exactly the mechanism, is that you're actually you're actually just moving an entire interaction web into the person simultaneously. And I think that really in many respects this program accomplishes almost like an in silico fecal transplant in many ways, because you're able to actually interact dynamically through not only primary interventions but also secondary interventions. And so, for instance, the other thing that, we were talking about the enemy of my enemy, is that, if I've got a bacteria I'm interested in inhibiting, and there's another bacteria that stimulates it, well, then obviously the program's not going to show you the things to inhibit it. It's going to show you, not the things to enhance it, it's going to show you the things to inhibit it.
I like to think of this as just like an ecological food web from like an old ecology class, in the same way that, at the top of the food chain, for example, are your biggest predators, the biggest nodes are your heavy hitters. So same thing.
The next app is Manza, which just basically gives you an insight into antibiotic resistance that might be able to be calculated by the presence of species and strains known to contain those particular antibiotic inactivating genes. So in essence, although you can't really say that necessarily that the particular site of the infection is antibiotic resistant, when you consider that the vast majority of antibiotics are actually taken by mouth and subjected to catabolic processes by the intestinal microbiota, knowing that there are microbiota in significant amounts that possess antibiotic inactivating genes allows you to reverse engineer that relationship and calculate out the presence and the degree that might be expected. So in this case, this person basically had a significant amount of tetracycline, penicillin, macrolide, and vancomycin inactivation. So in other words, vancomycin is typically given by IV, but tetracycline is certainly, and penicillin is certainly taken by oral administration. And the idea here is that, there might be some predictability that might actually be useful with regard to selection of appropriate antibiotic therapy. And the program does a pretty good job of giving you its underlying, nuts and bolts. Here are the genes that basically are known to have those inactivating components, and here are the species that are known to have those particular inactivating genes. and their presence on a percentage-wise basis. And again, you can send this on to the report as well. And then the last prescriptive is Proteus. Proteus, again, is really just a version of agency. If you're using the agency app in Opus to basically curate agents that you send on to the client report, that's what essentially Proteus does. And in this case, basically what it does is it takes the information from the algorithm program advice, and then it does a whole biome scan and basically calculates out the percentage of agents that are involved in the utilization of certain types of agents, and whether or not certain species basically need to be discouraged. But the other thing too is that it also gives you two-sided advice. It'll identify high-value targets to encourage and perhaps high-value targets to discourage as well. So very straightforward. For instance, to curate, you would just tick a box or two. What you're getting here is the result. So for instance, in this person, gallate is something that might be really important to encourage. I mean, you could use any number of different natural products. A variety of plants contain galates. The result type is consistent, which means that virtually every strain we looked at, there was no contraindications. There were no strains where this worked against them that we were desirous of having a beneficial effect on. Sometimes they'll be mixed. So in other words, you wind up in a situation where you have evidence that suggests that this thing should be discouraged and additional evidence that suggests for different bacteria that it should be encouraged. That'll give essentially a mixed result. So in this case, what we're seeing here is that resistant starch type 4 tends to be discouraged because there was more evidence that it would actually be problematic than it would be beneficial. There were 13 points awarded for being beneficial, but 20 points awarded for being problematic. So it wound up as a discouraged, but you have to know that there was, it was not a uniform consensus. So typically high value with very high consistent results are things that are going to be the kind of things you're going to want to be looking at with your client. And then a power factor, like you see, and whether or not, and this little icon here is telling you that a lot of these were actually in agreement with the agent data that was coming out of the advice program, the advice algorithm program. And again, we can send these on to Curation, and that is really essentially the story. Let's go back and put a couple of bugs in there, and we'll put a map in there. How's that? Let's go to Loam, and we'll put in some Cinderella. Let's put that in there, and let's put in a couple other things. Let's go back. Let's do Tara's thing. Let's sort by nasty factor. Let's put in some Cluvera, and let's put in we'll put in some Enterobacter. Okay, so we have some bugs, and I think we put in an algorithm. Did we curate an algorithm? So let's go back to advice. We'll curate an algorithm. Let's curate this one for autism, and let's curate this one. Okay. Now you have to redo it. But now you see the icon changed. Okay, so we've got a couple of algorithms. We got a couple of bugs. Let's go make a radiance map that we would like to hold on to. Let's see. I love Acromancia, so let's get some of that. This is probably good for them too, so let's improve that. This is another guy that's great that they don't have anything of. And let's see, let's find something. Oh, we should, Kristen Estella is great. Let's get some of that. And we hit that map. And here's our little map. Okay. Obviously, there's a lot more that you can do with this. So let's just curate this. We save that.
And add a Pansofia map.
Add a Pansofia map, she says. Okay. That is over here. Okay, so let's Oh, actually, there's two ways of doing that, so I'm going to hold off on that because you can actually do that from the curation itself. So you'll notice as soon as you curate something, all at the bottom it says curation. Now basically it's saying, hey, you probably want to make a report, so I might as well give you this option. So now basically you have to select what particular eubiome result you're going to base your report on. And so we're working with this one, so we'll select that. You can include Pansofia data, or you can print it out from the screen. We hit the button, and you'll notice in a different tab is the report data. So one of the things that I hope that we've done in this short film, and we'll certainly have some classes on this, is, oh, by the way, here's our agent recommendations at the bottom. And here's our antibiotic data, here's our interaction data. So one of the things that we're actually looking to do over time is to basically, get people as up to snuff on this as they are on genetic data. The program is a little different. You have to sort of become a little bit more comfortable with the way that the microbiology data is worked, and also to the nature of the slightly more complicated way of downloading the data. But the rewards are phenomenal, and the ability to track sequential data, to be able to come up with information that's going to generate agent-specific recommendations that are based on a total biome analysis, has a tremendous amount of benefit in being able to target therapies. And we've been using the module in the COE for maybe about a month and a half or two, and in difficult intractable digestive cases, it's actually done rather well. So I hope you've enjoyed this quick tour. I think that the best thing to do is, like I tell most people, get in there and get your hands dirty. Put out, if you get eubiome data, basically, that you can track to a client, get it into the program, go over to the Utopia thing and start clicking on stuff. And I think that, like most things, you can't break anything, but you can really learn a lot of stuff about the microbiome. There's so many people have told me that the Opus pop-ups have literally changed the way that they think about genetics, in the sense that they're coming in contact constantly with these informational pop-ups. They're becoming a lot more versed in carrying a lot of that information around a whole lot more readily than by sort of looking at it once and then forgetting it, only to have to learn it again. And it's the same thing with microbiome. I think by having the very rich intellectual environment that accompanies this, we'll gradually be able to refine the ability to have a language that we could use, or a way of communicating that's going to obviously get richer and more robust as time goes on.
And this is also a fairly inexpensive test and an easier stool test to do than some of the other tests, because it's not actually a catch of your fecal sample. It's a swab.
Right, you can get it off the toilet paper apparently.
Mm-hmm.
Yes, so my feeling is ultimately to try it and see if it enhances anything. I think but however, I think that with the actual ability to be able to meld this information and these analytics with the genetic data, it already marks Opus as a unique program that really there is no equivalent for. But the really exciting part is what's going to happen as we continue to grow the analytics and the data and do more of that integration of genetic information and microbiome data. That, I think, is almost like a brave new world. So thank you for watching this. Generally, like I say before, the most important thing is be in contact on social media. For instance, if you've taken the Dr. Greenfield webinars, you have your Facebook groups. You should be part of the DataPunk group. It's a secret group, so you might have to perhaps maybe contact Dr. Greenfield if you're not in the DataPunk group. Also, too, we will be doing some specialized training in the new year that will take place at the COE, and will be more of a multiple day affair where we can spend a little bit more time basically going into this. But I felt the best thing to do is to just kind of show you the fact that everything kind of looks the same and acts the same and behaves the same, and all the clicks pretty much do the same thing. So you shouldn't feel that this is going to force you to learn a new way of doing things, because it's really different things that being done in the same old way that we've been doing before. So thank you for taking the time to listen to this, and until next time, I'm Peter Diadamo.
Tarnick.
And this is the Utopia module of Opus 23.